Good afternoon and welcome to Agrifood Conversations, brought to you by iSelect Fund, the Van Trump Report, and the Yield Lab Institute. My name is Tom Bunn, an associate on the iSelect Fund team. Agrifood Conversations is all about driving innovation in agriculture. Each month we highlight a specific theme, including emerging topics such as soil health, plant genetics, vertical farming, and aquaculture, to name just a few. This month's theme is crop protection, and we will be exploring different technologies and angles that show promise in this field. Today we have Andrew Dipro, CEO of RootWave, with us. RootWave has developed a solution that uses electricity to boil weeds from the inside out, from the root upwards, effectively killing the plant in a clean, organic manner without the use of any chemicals. It's a sustainable, no-till, and effective solution that works instantly with no lasting issues in the field related to residues or drift. Each of you knows companies are more likely to succeed with the right network of customers, talent, investors, and advisors. We have invited you to this call because you are some of the smartest, most talented people in RootWave's market. You are potential customers for RootWave's products and services. You've built and sold a company in the agri-food industry, or you are a sophisticated business person or agriculture professional who understands the agri-food market and the challenges RootWave may face. A few process comments. We are not soliciting investment. This presentation is to provide information about RootWave's products and services to help them find customers, mentors, and other strategic relationships that can help them grow their business. You are all on mute. However, you can use the chat window to ask a question after the formal part of the presentation. Finally, this presentation is being recorded and will be available for replay. So without further delay, I'm pleased to introduce Andrew Dipro, CEO of RootWave. Take it away, Andrew.
Thank you, Tom. I'm just going to skip through a few of your early slides and pause before we get to ours. Okay, so RootWave. Well, thank you ever so much for all taking your time to over the next 10-15 minutes to listen to what I have to say. I believe it's a generally exciting area. I'm looking forward to sharing that all with you. Tom introduced our company very well. Effectively, what RootWave do is use electricity to zap weeds with zero chemicals. And what we're looking to achieve is to offer a scalable and sustainable alternative to chemical herbicides. So in my presentation, I've got roughly about 10 slides, and I'll walk you through the problem, the solution, and what we're doing about it. So the problem is very simple to understand. There's a growing need to control weeds as the world's population increases. And this is for food, infrastructure, and aesthetic reasons. Effectively, wherever there's human activity, there's a need to control weeds and keep nature back to some degree. This has predominantly been done to date using herbicides. However, that industry is under significant pressure recently for three key reasons. The first is resistance. So 2/3 of US farm acres now harbor resistant weeds. I understand a lot of farmers, some farmers in the US are now hand weeding weed. So it's a pretty significant step back that the industry has taken from that perspective. Weedscience.org tracks the latest statistics around resistance, and the latest numbers show that weeds have evolved resistances to 23 out of the 26 known herbicide sites of action, and that's to 167 different formula of herbicides across 70 countries. So they really hit home those numbers, how big a problem this is. And as nature continues to fight back, then this problem only is going to come and get bigger and bigger. The second issue is regulation. Countries around the world have started to ban or restrict the use of herbicides. In Europe, over the last 20 years, 65% of available pesticides have been banned. There are now 18 countries worldwide that have a ban or severe restriction on the use of Roundup, which is the world's most commonly used herbicide. And you've got ministers such as Merkel and Macron here in Europe who've committed to phase out the use of Roundup in their tendency because they believe that Roundup won't be relicensed when its extension expires in a couple of years' time. And finally, you've got litigation. Again, this is a US focused, and there's been there's been 3 recent trials which concluded in the plaintiff's favour, with total damages being awarded summing up to a couple of $100 million, with 18,000 plaintiffs waiting to go to court. So if you bring those 3 issues together, it just shows and highlights the pressures the industry is under and why an alternative solution is required. I believe that solution is the use of electricity. As Tom provided in his introduction, it's a very simple and elegant solution. Effectively, what you do is you touch a weed with an electrode, and that establishes a circuit which electricity flows through. The natural resistance of that weed changes that electrical energy into heat, which boils it inside out from the root upwards, killing the weed. There are 3 key advantages that I like to talk about. The first is it's sustainable. So not only is the technology organic, but it doesn't use water. And in some areas of the world, water is becoming increasingly precious. And also it can be powered from energy taken from a battery, which can be recharged from green energy such as solar or wind. So you can have a completely green and sustainable technology. The second is no till. So because we can touch the weed above the surface and it treats above and below the surface, that means you don't need to disturb the soil. And if you disturb the soil, it has a host of disadvantages, including soil erosion, carbon emissions, and disease. And it's actually one of the primary benefits of using chemical herbicides, the fact you don't need to till your land. And finally, it's low cost. So we have some recent trials that have concluded it's cost comparable with using herbicides. And if you look forward into the future, where you take your energy from locally produced green sources such as solar or wind, then actually you can have a 0 input cost weed control solution. Now, the EU Commission and the UK governments have recognised the issues at hand and the potential of the technology, and they've granted us a couple of £1 million over the years to drive this technology forward. And we have patents pending and granted to ensure we're the gatekeepers of this technology for the foreseeable future. This slide just talks about some of the other technologies out there to control weeds and where I see our advantages being. With herbicides, there's the issues of resistance regulation and litigation, which I've touched on, and they cost a lot to develop, £250 million or dollars, and generally take 10 years with no guarantee that they'll be licensed at the end of that. And then also you've got issues of drift, where neighbouring crops can be damaged from the herbicides drifting. This is similar to biopesticides as well, but with biopesticides, I also understand that there are no real broad spectrum solutions like there are with glyphosate Roundup. So it's a targeted solution. Electricity is broad spectrum. With thermals, this is generally hot water, steam, and laser, etc. A couple of issues here. One is they're inefficient, so they use a lot of energy. A lot of energy is lost into the surrounding soil and air, etc. And also because that heat is applied externally to propagate down into the soil, it doesn't necessarily kill the rootstock. With mechanical weeding, this is tilling, and we've spoken about the issues around soil erosion, carbon emissions, and here. And then the last solution is the manual weeding, which is obviously slow and disturbs the soil and is expensive. Now, as a company, we're a small startup, and we recognise that if we're going to solve this global problem, we're going to need help. So what we've decided to do is to focus on the kill, the zap, and then scale by selling or licensing that technology to partners to integrate into existing best-in-class weeding platforms. And these will provide the vision technology, if it uses automated technology, and also the touch, the mechanical way of touching the weed. If you bring the see and touch together and kill together, then you've got the overall solution. For example, in agriculture, we're currently working with 3 machinery partners. There's Steketee in the Netherlands, and we're developing a solution that's pulled behind a tractor, has a vision technology to spot weeds in and around cereal crops before zapping them in an automated fashion. Then there's SFM technology here in the UK. We're developing a solution for fruit crops to recreate the herbicide strip to reduce competition in and around crops such as blackcurrants, chuckleberries, grapes, etc. And then finally, there's a new project we're starting with Small Robot Company in the UK, and that's to create a fully autonomous weeding robot for cereals, where the vision technology looks at plants by plant and then decides what to do, or if it's a weed, and then whether or not to zap it or not. So between those solutions there, you can understand where we're heading, and we will continue to integrate with more and more partners in order to scale this technology across different crop types and geographies globally. This slide just gives you an example of the efficacy of technology. So the top 2 photos are a first trial where we are running along the rows of fruit crops. The bottom left is the results 2 weeks later, so roughly about 95% efficacy. And then the photo on the bottom right is a control. So effectively, that's what happens if the ground wasn't zapped. A big difference, as I'm sure you can appreciate. We do have an existing professional hand weeder. This is based on older technology, so is a little large and heavy, but extremely effective. It's being sold directly in the UK and via distributors internationally. And we have units operating in the UK, Canada, Netherlands, France, Germany, Jersey, Ireland, South Korea, and New Zealand. Customers are people that are managing land in parks and gardens, such as Arsenal Football Club or English Heritage. And also we've had a huge amount of customers recently buy it to treat invasive species such as Japanese knotweed and giant hogweed, which are rhizome. Well, the Japanese knotweed is a rhizome-based weed, which is typically very difficult to get rid of. And there are no real non-chemical methods that do the job. And actually, even herbicides, the evidence suggests that the Japanese knotweed goes into dormancy rather than it being killed, which is where electricity helps. In the future, this will become a battery backpack, very similar to a chemical knapsack that is used today. And this will be great for municipals and councils, for example, to walk along the various streets, zapping the weeds as they go. This slide doesn't really say much. It's just a reminder for me to comment that it's not just organic farmers that are interested in this technology, because it can be cost comparable with herbicides and is an organic and sustainable approach. And then actually we've got the interest of some of the top tier agrochemical companies in the world. And we're now actively working with them to validate the technology, which is going well, with the next step being to potentially work together so they can offer to their customers chemical approaches and or the use of electricity to complement or in some areas supersede that. That kind of brings me to the end of the presentation. It's relatively brief and high level. Very welcome to speak to anyone that is interested in the technology. how I summarize it is that we're solving a global problem with a superior technology, one that will have positive health and environmental benefits in a market driven by resistance, regulation, and litigation. There is obviously a lot more to talk about and a lot more detail, but as an introductory presentation, I feel that's probably the right level. So that concludes me, Tom, so back to you.
Great, Andrew. Thank you very much for walking us through that very informative presentation. I'll go ahead and ask a couple questions. So are you seeing efficacy across growing seasons, or you have to use the same intensity of the RootWave solution every growing season, or does it diminish over time?
It diminishes, and because we kill the weed, so the weed's gone, and there's lots of weed seeds, seed banks, left in the soil, so new seeds grow into weeds. But over time, as you keep on treating those weeds, obviously the seeds diminish, and eventually, it trends towards zero.
Got it. And can you talk a little bit more about the regulatory pathway? I know one of the big components that you touched on is the 10, 11 years to develop a new method of action and the very expensive needs for developing that. What's the regulatory environment you face both in Europe and in the US, and can you give a scale of kind of timeline and dollars needed to overcome the regulatory hurdles?
Yeah, I mean, the crux of this question is that there are no regulations for the use of electricity to kill weeds. And typically what happens is you implement a technology and the regulators catch up. So I believe that regulators won't block this going into the market. They may have a few things to say after it's already in the market, but then it's already there. So for me, regulation is not an issue. Now, we do have to, obviously, there are some regulations around our machines, but they're more based around electricity and electronic hardware. So in Europe, we have something called a CE mark, and effectively what we'll be doing is comparing our technology against very well-established CE regulations for power supplies, and the US has something similar. So it's very different in that there are no regulations. So we'll use what there are. I don't see any issues with them because they're very well defined and everyone knows about them. But in terms of specific regulations for electricity, there are none, but I expect there will be at some point in the future. We've done loads of studies on soil damage and damage to invertebrates such as worms, and our studies suggest that they're okay. There's no issues in that respect. So I can imagine that's where regulators would be most interested. I mean, the underlying point is once you turn off the electricity, our technology doesn't exist in that field anymore. There's no issues of runoff. There's no issues of residue. There's no issue of drift or anything like that, which is obviously the key concerns for regulators today in terms of the potential downstream impacts of a technology when used for crop protection in agriculture.
Got it. And do you see this as a wholesale replacement for herbicides, or do you think there'll be a mix of method of actions, both chemical, biological, and kind of physical or electrical, or again, are you a wholesale replacement for the weed control?
I think with any problem there are multiple solutions, some of which suit different people over others. As a small company, as a startup, we're targeting the area that we're launching in. As we grow, then we'll expand that area, and ultimately, I want to be able to have a technical solution for every different type of weed scenario and every different type of crop. So we will have the ability to wholesale replace herbicides, but I'm realistic in knowing that not everyone will choose our technology, and there will be a selection of technologies that people choose between.
Got it. And can you give an overview on sort of how many acres you guys are on now, and where you are with some of the development partners, and what kind of the rest of 2019 and into the initial growing season of 2020 looks like, and where you'll be?
Yeah, sure. So if we look at professional hand weeder, that is a product that is past regulations, and that is being sold globally. It's less for agriculture because it's not a solution for large acreages. But having said that, some organic farmers have bought it to control docks, for example, or giant hogweeds on their land. When it comes to the more automated solutions, we've got these 3 projects ongoing with our partners. We hope the first one will conclude with Steckity towards the end of the year. There'll be a soft launch in Europe next year, and a more global launch the year after.
Great. And what's the biggest challenge? What's the biggest thing keeping you up at night right now?
I think it's the same every startup experiences, which is money. So we've proved the technology, we've proved the business case for it, but this is a hardware innovation, and that takes time and money to get right and to scale.
Got it. Understandable. We know those challenges. Well, great, Andrew. Thank you again for your time. To conclude, I always like to offer the listeners and the audience a way of reaching you. Where can you be reached by any of the attendees and listeners who would like to reach out?
The best way would be to email me. So that's andrew.diprose@rootwave.com.
Great. Fantastic, Andrew. Well, thank you again for your time. We really appreciate it. Congratulations on the progress to date, and best of luck in going forward in 2019 and beyond. To those attendees, as a reminder, we host these calls every week at 3 p.m. Central, every Thursday at 3 p.m. Central. You can register for these conversations by going to agrifoodconversations.com, and a replay of this webinar will be emailed to you in the next 24 hours. So if you know others that may want to see this webinar and replay, they can register on the original webinar link to gain access. So please share liberally and distribute to anyone you think might be interested. So thank you all for your time, and we will see you next week at 3 p.m. Central. Thanks again, Andrew.
Thank you.